Today we shall discuss about the general form and the graphs of different polynomials. At first, linear polynomial. What is the standard form or general form? P of x is equal to ax plus b. If this p of x is written in the form of y, that will be y is equal to ax plus b. What is the condition? A not is equal to 0. You must have to write this a not is equal to 0. What will happen if a equal to 0? Now if a is equal to 0, then you see 0 into x, that is, this term will vanish. It fails to be a linear polynomial. That's why the condition is given a not is equal to 0. Okay. Now we will see the graphical representation of this linear polynomial in the form y is equal to ax plus b. You see, this is the graphical representation whenever a less than 0 and b greater than 0. If a is greater than 0 then and b is greater than 0, then the graph will be like this. If a and b both are less than 0, then the graph will be like this. And if a greater than 0 and b less than 0, then graph will be in this form. You see, these straight lines are this linear polynomial. These straight lines represents this linear polynomial. But you see, in linear polynomial there is no condition, no restriction for b. That means if b becomes equal to 0, then the graph will be passing through the origin. If b is equal to 0, a less than 0, then like this, and b is equal to 0, a greater than 0, then the graph will be like this, passing through origin. Now, for the quadratic polynomial, what is the standard form? The standard form is, or the general form is, ax square plus bx plus c whenever a not is equal to 0. If this p of x is written in y, then it can be written as y is equal to ax square plus bx plus c. Then a is not is equal to 0. Why a not equal to 0? Now if a becomes equal to 0, then 0 into x square, that will be 0. This term will vanish. So this polynomial will fails to be a quadratic polynomial. Now see the graphs. If a is greater than 0, that means the graph will be like this. You see, this graph intersect x-axis at 2 points. That means why 2 points? As a quadratic polynomial has 2 zeros. Here you see 2 distinct zeros. These 2 zeros are different. But here you see these 2 zeros coincide. That means 2 zeros exist, but both these 2 zeros are same. And here you see the graph of this polynomial has not intersect x-axis. That means there exists no such value of the variable, no real value of x for which the value of the polynomial becomes 0. That means in this polynomial there exists no 0 of this polynomial. In all these 3 cases, a is greater than 0. Very interesting feature for this graph is that you see the number of curve, that is 1 in all cases. That means the degree of this polynomial, what is it? For quadratic polynomial, the degree of the polynomial is 2. The number of curve will be 1 less than the degree of that particular polynomial. And if a is less than 0, then the graph will be like this. In first case you see there are 2 distinct real zeros. Okay. In the second case, these 2 zeros coincide with each other, that is 2 zeros but only one value. And here there exists no such real 0. Now the general form of the cubic polynomial. What is the general form of a cubic polynomial? That is p of x is equal to ax cube plus bx square plus cx plus d. Again the condition is a not is equal to 0. The reason is same. If a is equal to 0, then this polynomial fails to be a cubic polynomial. So if it is written in the form of y is equal to ax cube plus bx square plus cx plus d, then we can draw the graph of this polynomial. This is the graph of a cubic polynomial. You see how many curves are there? As I told previously, that is the number of curve. This is one curve and this is another curve. That is two curves are there. Number of curve in the graph of a cubic polynomial is 1 less than the degree of it. Here the degree is 3, 1 less than it, that is 2. So there are two curves, and you see this graph intersect x-axis at 3 distinct points. That means 3 real zeros, 3 distinct real zeros of this polynomial, cubic polynomial. Here you see there are, in this second case, there are also 3 zeros, but 1 zero is coincide. The standard form of such type of cubic polynomial will be this, and here all the 3 zeros are coincide. Okay, these are the 3 examples of 3 cases.